Welcome back, everybody. AP Calc. Today's topic 2.5, applying the power rule. Also, topic 2.6, derivative rules, constant sum, difference, and the constant multiple. So, first, we're going to be looking at the basic differentiation rules, which is pretty much the constant rule right here. And then the derivative of a constant function is zero. That is, if c is a real number, then the derivative with respect to x of the constant c is equal to zero. And then the special case of the power rule will be right here. If whenever you have x to the first power, the derivative of the function x with respect to x is equal to 1. All right. And then the other power rule, so if n is a rational number, then the function f of x equals x raised to the n is differentiable, and the derivative with respect to x of x to the n is equal to n times x to the n minus 1. And then for f to be differentiable at x equals 0, n must be a number such that x raised to the n minus 1 is defined in an open interval containing 0. So this is just pretty much to prevent that you guys have like 0 raised to the 0 in your interval. So we have to be careful, right? Because remember, that's the indeterminate form. All right, so we're going to be seeing how we apply these rules. All right, I'll show you guys a proof of this later on, which is actually really nice. So it's just pretty much just the basic rules, right? So one of the things that I need to point out here is that we've talked about f prime of x, right? And now if you've noticed, you've seen this notation d of d dx, right? And then usually f of x goes in here, right? Whatever the function is. So these two are equivalent, right? Whenever you guys see these two, they're always talking about the first derivative of x, right? And then there is actually more than one derivative. So we'll discuss those later on. So let's see. Well, we have an example one. It says find a derivative of each of the following. We have a is f of x equals x to the fifth. So here, basic steps you guys want to do. So this is where we're going to apply the power rule. So n equals 5, and then n minus 1, right? Pretty much 5 minus 1 is just 4. So again, the power rule is x raised to the n, right? If I take the derivative of that, that's going to be equal to the n times x to the n minus 1. So it's just pretty much identifying what we have here, right? Which is going to be, again, the number that's going to be multiplying x. And then your new exponent is going to be n minus 1. So it's pretty simple, pretty straightforward here. We would say f prime of x, right, equals 5, which is our n, times x raised to the fourth power. And that's pretty much it. So what this does, it gives us the ability to know the slope of n at any point, right, in the function x to the fifth power. So if you like, looks pretty similar to a cubic function. So this will give you the slope at any value of x here, the slope of the tangent line. So now example B, we have g of x equals the fourth root of x to the third. So whenever you guys see roots, the first thing that should be pretty much back in your mind is like, how can I rewrite this with a fractional exponent, all right? So always rewrite as fractional exponents. So here we have g of x. So we're going to rewrite this. Remember, this is a denominator, and this is going to be our numerator. So x to the 3/4. And now again, I move forward, right? This is my new n. So this is n equals 3/4. And then n minus 1, or 3/4 minus 1, will be pretty much negative 1/4. So here, our new n, our n is 3/4, so that would be 3/4. So g prime of x equals n, 3/4 times x raised to the new exponent, which is negative 1/4. Now remember, most of the time you guys are not going to see, you might see it in a different form. So a negative exponent, that would be, for example, 3/4 x to the 1/4. You might see it this as 3 over 4, and then the 4th root of x. So again, your answer might come in those three different equivalent forms. So make sure you guys keep an eye on things on when you're rewriting it, when you're simplifying it. Most of the time, you're going to see positive exponents. All right. And then the next one now, if you notice here, we can't say that n is equal to 3, right? So be careful. Whenever you see a denominator, right, the exponent in the denominator, you want to make sure that you rewrite it with as a negative. So this would be x to the negative 3. Now I can apply the power property or the power rule for derivatives, which would be n equals negative 3. And then n equals negative 3. And then over here, n minus 1 would be negative 3 minus 1, which is negative 4. So we're going to have y prime equals, and then n, which is negative 3, times x to the negative 4, which is our new exponent. And then again, rewrite it with a positive exponent. So this would be negative 3 over x to the 4th. And that's y prime. Now we move on to the next rule, the constant multiple rule. So that was for the first one, was pretty much the power rule, right? Now we're going to see what happens when we have a constant in front of a function like this, right? So find the derivative of each of the following. And if you guys notice, just like if we're able to move the constant out, then it's just always going to be multiplying. So here, find the derivative of each of the following. Part A is y equals 2x to the 7th. So we're looking for y prime. All right. So here again, another thing that you guys want to identify is the constant. So the constant is what's multiplying the x in front of it. So this would be 2. And then our n, right now we start applying the power rule, is 7. And minus 1 is equal to positive 6. So 2, right, just moves out of it. It just stays there. And then we're going to apply the power rule, which was 7. So that's 7 right here. And then times x to the 6th power. And then we simplify that, and that gives us 14x to the 6th. So that's our y prime. So again, pretty much whatever you guys had on the outside right here, you're just going to multiply by the n that you get out of the power rule. So let's look at example B right there. So this is g. We're looking for g prime now, g prime of x. So we want to rewrite this again first with a negative exponent. So this would be 3 times x to the negative 2. And then this equals, again, your constant is 3. So that's just pretty much rewrite it, 3. And then our n is equal to negative 2. And then n minus 1 is equal to negative 3, right? So negative 2 minus 1 is negative 3. So negative 2 is our n. And then x raised to the n minus 1, which would be negative 3. Again, simplify. G prime of x is equal to 3 times negative 2 is negative 6 times x to the negative 3. And then again, rewrite it as with a positive exponent. So negative 6 over x to the 3rd power. And hey, that's our g prime. So the last one, again, now we have square roots. And like I mentioned before, make sure you guys are rewriting these with as a fractional exponents, right? So fractional exponents, don't forget that. That way you can start manipulating, you can start applying the power rule. If not, you're not going to be able to apply the power rule. So make sure you guys are careful with that. So here, this is going to be equal to, this is again our denominator, our numerator. So that's going to be x to the 5 over 6 over 8. Now here, there is a constant. So you guys want to be careful. Make sure that you identify the constant. If you have the denominator, your constant is 1 over 8, right? I can rewrite it so I can see that clearly. And then x to the 5 over 6. So this is my constant, which I'm just going to put in front, right? So f prime of x equals 1 over 8. And then n is equal to 5 over 6. And then n minus 1 would be, take away 6 over 6, so that's going to be negative 1 over 6 times x to the negative 1 6. And then again, simplify. So you're going to get 1 over 8, right? Oh, I forgot. I missed my n right there, which was 5 over 6. I forgot to put that in there. So times 5 over 6, and then x raised to the negative 1 6. And then again, simplify further as much as you can, right? Like you want to make sure you have a single fraction. So that's going to be 5 over 48. And then this has a negative exponent, so x to the 1 6. So that's your f prime of x.